Hi, hello, good evening, one and all. Welcome to the session. Welcome to Gradeup. Please let me know whether this audio and video both are clear or not. Just give me a second so that I will share this session too. If anybody is there, please let me know whether this audio and video both are clear or not. Can you tell me? Can you confirm this one? Hello. All right. So just give me a second. I'll even share this session so that it will be quickly you can join in. By the way, in the last session we had a discussion, I think, on the, the time domain analysis and frequency domain analysis questions we did. Okay, we have taken up the models, and most of the times definitely there will be question on first order circuits or otherwise second order circuit. So please concentrate more on first order circuits and second order circuit. Definitely every, let it be gate examination, let it be ESC examination, definitely there will be a question on first order circuit and second order circuit. And there is one more important topic, so-called two-port networks, right? Let's see now. Let's see. Before moving on to the session, let me tell you something about myself. Myself, Naveen Gollapalli. I have around 7+ years of experience in teaching. Most of the times, I'll be taking electrical machines measurements and by the way, this is my Telegram channel where you can join in for the study material updation, or, updates or notifications, or if you have any doubts and questions, you can post here so that I can respond. Okay, my dear. This is all about Gradeup Super Platform courses. These are the classes. Vision 2022 is a course for those students who are preparing for 2022 GATE examination and ESC examination. And this course is available even in Hindi also. So the language based. If you are very much interested in Hindi, you can join in here. The course features are going to be same, but the only difference is content is also going to be same. But the only difference is faculty is going to deliver the lecture in Hindi. And by the way, same is for 2023 aspirants also. So if you are planning for 2023 GATE and ESC examination, and this is the best course for you, I can say. And moreover, if you want some more details, about this course, you can call to this contact number. All right, my dear. So this is all about champion study plan, where uh, most of the subjects are lined up. After networks, analog electronics, and then it goes on. So we are going to concentrate on important topics only, and from that we have taken the model gate questions and we are trying to solve in front of you. Okay. The theory session is going to be on app, and practice session will be on YouTube. Right, my dear. Come on, my dear. Everybody, those who are online, can you tell me, uh, is this audio and video both are clear now? Can you confirm from your side? Hello. Let me check from my side if there is an issue. Yeah, from my side it is clear. All right. Can you confirm, guys? Can you confirm once? Is there any audio issue, video issue, so that we can move on? Clear? Okay, done. Thank you, Sarita. Chalo. Have a look at this question. Have a look at this question. The Z parameter of the two-port network shown below is given by. Below means here. Okay. So you can see 10 ohms, 10 ohms all, and in between 1 ohm is there, 10, 10 is there. Now he's asking Z parameter network. Can you post your answer in the comment box so that we can move on? Gayatri, okay, thank you. Can you post your answer? What will be the Z parameter? Meanwhile, I'll write the formula. You can post your answer in the comment box so that we can discuss. So your voltage and current equations will be like this: V1 is equals to Z11 into I1 plus Z1 and Z12 into I2. And by the way, V2 is equals to Z21 into I1 plus Z22 into I2. By the way, if you if you take up, these are the equations, by the way. And if you look at the matrix form, then Z parameter matrix will be simply, the input impedance, the sum of resistors connected in the input loop is going to be Z11. That is what we call it as input impedance. And in the output side, output loop impedance, output loop, the sum of the resistors connected in the output loop is going to be output impedance. And transfer impedance is going to be between 1 and 2. Between 1 and 2. Between input loop and output loop, whatever the resistors are connected or whatever the impedance is connected, that will be the transfer impedance. So that will be written as Z12 and Z22, right? So can you tell me? Can you tell me what is the answer? People are saying Vignesh is saying C and Sarita is saying C. Very good, super. So input impedance 10 plus 10, 20 and 2, 1 plus 1, 22. So obviously 22 means B and A should not be the answers. So input impedance is going to be 22, output impedance is also going to be 22 and transfer impedance is going to be the middle one, 2. Alright, so C could be the correct answer. Let's see one more question. Look into this question. If you remember the formulas, you can do it, sir. Come on, guys. Post your question. By the way, I'll write in between y parameters equation. So it will be I1 is equals to y11 into V1 plus y12 into V2, and I2 is equals to y21 into V1 plus y22 into V2. The same way, y parameter, y11 input admittance, y22 output admittance, and y12, y21 transfer admittance. Here you cannot do this one. Here you cannot simply input admittance is nothing but the elements connected to the input node. The sum of the elements connected to the input node. By the way, reciprocal. Here it is ohmic value. Okay. Here admittance Mohs. So reciprocal of sum of reciprocal of elements connected to the input node. Be careful. So you cannot apply that one. So what is the other way? You have to either go ahead with the matrix or otherwise go ahead with the formulas. Can you tell me what could be the answer? Can you tell me what could be the answer, my dear? Y parameters is asking. Y parameters. Let's see. Let us calculate y11, y22 or y21, y12. Okay. Remember, if matrix form is not going to work out, and you take the help of these equations. If you wanted to calculate y11, simply make v2 equal to 0. Short circuit analysis. Simply make v2 is equals to 0. Then y11 is equals to I1 divided by v1 when v2 is equal to 0. So if v2 is equals to 0, so this is I2 direction. I2 is equals to, I can write it as I2 is equals to minus 2 times I0 or not? Minus 2 times I0, because quite opposite. Right. What is I0? What is I0? I0 is going to be directly I1 or not? So this is your input side, excitation or input side. Or otherwise I can say 1 dash terminal. Generally we call it as input port and right side port is called as output port. Okay. So at the terminal 1, I1 is going to enter. So I1 is equals to I0. So I can replace now. I2 is equals to minus 2 times I1. I2 equals to minus 2 times I1. Now what I wanted to calculate, I want to know V1 value. Let's calculate V1. If you write loop equation, if I1 is flowing through 1 ohm resistor, I1 into 1 ohm drop is going to take place. So plus V1 minus 1 times I1 is equal to 0. Because this is a short circuit, no? So it is a 0. So V1 is equals to I1. V1 is equals to I1. So if V1 is equals to I1, I can write I1 divided by I1. You will get it as 1. Y11 is going to be 1. So how many options are going to have 1? A and C are going to match. A and C are going to match. Sarita is saying A and Hemant Sai is saying C. Others also. Can you respond? Let's see. So if this is matching, look into the Y21. Y21 is nothing but what? Y21 is nothing but when V2 is equals to 0, Y21 is going to be I2 divided by V1. I2 divided by V1 is equals to Y21. I2 I know that is minus 2 times I1. What is V1? I1. So I1 gets cancelled. You are going to get minus 2. So C is the correct answer. Is it clear, my dear? So from the equations, you can do it. If the Y parameter network is not given in pi model, then this can't help you. So equations will definitely help you. All the times equations will help you. So whatever the elements you wanted to find out, you just make other term as 0. You try to calculate. Is it clear? Very good, Sarita. Right. Let's see one more question. H parameter. H parameter. Can you respond? What is this answer? Can you comment in the comment box the answer for this question? H parameter is asking H11 and H12. So there might be possibility of MSQ also. Please check for that also. Right. So let me give you the equations. V1 is equals to H11 into I1 plus H12 into, this is H12 is going to be probably forward voltage gain or reverse voltage gain. Yeah, reverse voltage gain, I think so. Okay, let me take up V2 and I1 is equals to H21 into I1 plus H22 into V2. Okay, if you remember the formulas, then that's fine. Can you tell me what is the answer now? H11, which options are going to match? By the way, I forgot to write, sir. I forgot to write. You know, sometimes they'll ask you in engineering service examination, sometimes for 1 mark, Z11 is equals to Z22. If this is going to match, then I can say that this is going to be a symmetrical network. Then Z parameter network is going to be symmetrical. Z12 is equals to Z21. Then this is going to be reciprocal network. If Z21 parameter, Z12 parameter are equal, here in this Z21 and Z12 are equal. So this is a reciprocal network. Right. Similarly, here also even. Let me write that condition. Y11 is equals to Y22 is symmetrical. You can call it a symmetrical network. And Y12 is equals to Y21. You can call it as a reciprocal network. Reciprocal network means it has to satisfy reciprocity theorem. That's it. Okay. So here this condition will be H parameter. Na? So H11, H22 minus H12 and H21 is equals to 1. Symmetrical. Condition for symmetrical circuit. And reciprocal will be obviously, I forgot to write, will be H12 is equals to H21. Okay. Yeah, symmetry and reciprocal. Symmetry and reciprocal, this one. Is it so? Can you tell me what is the answer for this one? A and B both are matching. Let's see. Let's calculate H11. H11, if you wanted to calculate H11, you have to make V2 equal to 0. So make V2 equal to 0 means short circuit. Right? Short circuit. If there is a short circuit, this J5 inductor and short circuit both are connected in parallel. So no current will flow through this J5. So if you connect a voltage source across input terminals, this I1 will flow through 2 ohms and short circuit and comes back. So plus V1 minus 2I1 is equal to 0. Or V1 is equals to 2I1. V1 is equal to 2I1. V1 by I1 is nothing but V1 by I1 is nothing but H11 or not. So it will be input impedance. V1 by I1 is nothing but input impedance, right? 2 ohms. H11 is going to be 2 ohms. So 2 ohms should be given actually. V by I is nothing but impedance, no? Right. So H11 is not 0. Calculate H12. Calculate H12. H12 means you have to make I1 equal to 0. You have to make I1 is equals to 0. So when you make I1 equal to 0, when you make I1 equal to 0 means open circuit, no? I1 equal to 0 means, let me write in the next circuit. This is 2 ohm, this is J5, and here this side I am going to apply V2. So here I1 is equals to 0. If I1 is equals to 0, then V2 is going to deliver I2 and that I2 flows through the J5. So V2 definitely is equals to J5 times I2 or not? This is V2. Now I want V2, I want V1, V1 also. So what is V1 voltage across this open circuit terminal? You are going to get it as V1 also equals to J5 times I2. So H12 will be 1. Okay. Simply you have to take up the help of equations. It will be very quickly you can do it. Okay. Right. So this this kind of questions you can expect in gate, where control systems and networks you can mix up and you can calculate. Chalo mind. Try to understand this question. Try to understand this question. थोड़ा सा time लेता है बस नहीं. But you should have a patience. If you get an idea, then you can do it. A two-port network has zero initial conditions. At t equal to 0 has zero initial conditions, full stop. At t equal to 0, an impulse voltage del of t is applied at the input, producing a voltage e power minus 2t plus e power minus 3t into u of t volts at output. Is giving del of t, impulse input. So getting this value. So it's an impulse response or not? In the control system, we will write it as, if you give this impulse input, it will be output will be impulse output. Impulse response we say. If you give step input, the response will be step response. So like that we will. Whatever the input you give, the output is trying to follow, right? Because we take up linear time invariant systems. So that's the reason why. So it's an impulse response, I can say. Impulse response is nothing but system response. So if the output required is t into e power minus 2t u of t, then the input voltage will be. Alright. So I have a system. So I have an output of e power minus 2t plus e power minus 3t into ut. By the way, the input is going to be del of t. So this is you can write it as C of S, output as going to be C of S, input is going to be R of S. Or otherwise V2 divided by V1, anything is okay. So C of S divided by R of S, Laplace transform of input, Laplace transform of output divided by Laplace transform of input. You can take up. So I can take up, this is in time domain. You can't you convert into a frequency domain? So you'll get the Laplace transform if you apply. So it will be S domain. In the S domain, it will be 1 by S plus 2 plus 1 by S plus 3 divided by Laplace transform of del of t. Del of t, Laplace transform of impulse is going to be 1 or not? So this is a value. You can calculate now that this is you call it as transfer function or system function. System, even H of S also you can call it as. Because R of S is going to be simply 1. It will be S plus 2 into S plus 3 numerator, and denominator probably it will be S plus 3 plus S plus 2. So probably 2S plus 5, right? Instead of writing this lengthy one, 2S plus 5. So this is a system transfer function. Now for this system, he's getting, once again, he's getting t into e power minus 2t. If you want to get this kind of output, what should be the input voltage you need to apply? Can you respond? Superb, Hemant Sai, superb, very good. Is it first option only? Hemant Sai is saying only first option. Is it not satisfying third option? Let's see. So now I have H of S. Now I need to calculate the input. My output is here t into e power minus 2t into u of t. Okay, there is my input, R of S. By the way, you can take up the Laplace transform 1 by S plus 2. T is there, so T is there means repeated. So it's S plus 2 whole square. This is my output. Now take up the input. So how do you get? Transfer function is going to be obviously C of s divided by R of s. I wanted to calculate R of s only. So C of s is 1 by s plus 2 whole square divided by h of s. I have got it as 2s plus 5 divided by s plus 2 into s plus 3. Okay. Is it okay? So s plus 2 whole square, s plus 2 gets cancelled. And you can get this as s plus 3 divided by s plus 2 into 2s plus 5. You can take up 2 as common. If you take up 2 as common, s plus 5 by 2. So this is how it looks like. So probably s plus 3. And anyhow, you can go ahead with the partial fractions. If you go ahead with the partial fractions, probably you are going to get. I'm not going to take up the partial fractions. Simply you can take up. So the pole terms are going to be the powers of exponential term, right? So I'll be getting e power minus 2t and I'll be getting e power minus 2.5t. So your answer should consist these terms after applying inverse Laplace transform. I'm saying, okay, take up the partial fractions, then apply your inverse Laplace transform. The pole terms, whatever the pole terms are there, those pole terms are going to be your exponential powers. All right. So e power minus 2t is there, e power minus 2.5t is also there. So B and D options are not going to be matched. So if you have to solve. Anyhow, this magnitude is there. Probably this might be matching. ARC is going to match. ARC is going to match. You can solve. Maybe any one of that is going to match. Anybody? Only Hemant Sai is saying that only A option. Others? Please let me know if you have any confusion. I think this kind of questions you might have done in the control system also. Probably first option is going to be the answer. If you do partial fractions, you'll get it. Okay. Look into this one. The Z parameters of the two-port network shown in the figure are given by. This is a network. We want Z parameter. Right. Z parameter. So calculate. Z parameter. Input impedance is going to be V1 is equals to I1 into R1 or not. So Z11 is equals to R1. R1, R1, R1. So D option is not correct. Next. Let us calculate in some other way. Maybe Z22. Z22. So Z22 output loop impedance. So V2 is equals to I2 into R2. I2 into R2 minus alpha times V1. Minus alpha times V1. So what is V1? You can substitute here probably. Right. So I2 into R2 minus alpha times. What is V1? V1 is equals to I1 times R1. So it is going to be a very lengthy one again. Let us not do like this, by the way. Better to go ahead with the equations, then it will be very simple. Whenever you're trying to find out this one, whenever you're trying to find out the input side, current is going to become 0, right? I2 you have to make it 0. That means what? Open circuit. Means what? Open circuit. Right. So let's see. V1 is equals to I1 into Z11 plus I2 into Z12. I made I2 equal to 0. I made I2 equal to 0. So I am able to calculate Z11. Similarly, other parameters also. Z21 into I1 plus Z22 into I2. If you make I2 equal to 0, you can calculate Z21 also. That is V2 divided by I1. V2. What is V2? V2 is the voltage across these terminals. V2 is voltage across these terminals. So V2 you will get it as, anyhow I2 is equal to 0. If I2 equal to 0, there is no voltage drop across R2. So you will be getting it as minus alpha times V1. Let me hide if it is not visible. So V1 is going to be I1 times R1. Now I need V2 by I1. V2 by I1 is equal to minus alpha times R1. Minus alpha times R1 is Z21. So Z21, this is not matching. So C could be the correct answer. Bhavesh, actually, it's like, we are in the champion study plan. We are taking the most important topics, and based on that, we are taking the questions. Not like entire network theory. Like for gate examination, we are concentrating, right? So most probable areas from where the question is going to be appeared. So that areas we have picked and we are taking. Bhavesh, is it clear for everyone, my dear? C could be the correct answer. C could be the correct answer. Come on, my dear. Look into this question. Look into this question. In the two-port network shown in figure, the mutual inductance of coupled inductor is M. Mutual inductance of coupled inductor is M. The Z parameter matrix of the network is, we want Z parameter matrix, like Z11, Z22, Z12. So simply if you want Z, you find out VI relation, that's it. Voltage and current relation. Write a loop equation here, write a loop equation here. Okay, first loop equation plus V1 minus j omega L1 minus j omega L1 into I1. That's a drop. Okay. I2 is going to produce phi 2 because whenever there is a current circulation, there will be flux production. Now this phi 2 is going to link with the first coil. So whenever phi 2 is going to link with the first coil, you will be getting a mutual EMF because other coil flux lines are linking with the L1. Okay. So, when I1 is flowing, phi 1 will produce. Phi 1 will link with its own coil and also link with other coil. Okay, that mutual, whenever you get a linkage of flux lines of another coil, that is called as mutual induction. Okay, own coil flux linkages, you can call it as self induction. So take up that minus j omega m mutual inductance j omega m times I2. So if you send out to the right side, probably you'll be getting it as this way. And similarly, second out, otherwise secondary side, if you can write equation, V2 is equals to j omega L2 into I2 plus j omega M. When phi 1 is producing, phi 1 is also linked with second coil. Phi 1 linked with its own coil and also linked with second coil. Phi 2 linked with its own coil and also linked with other coil. Alright. So that way you have to subtract the mutual induction and then you'll get this equation. So what could be the correct answer? What could be the correct answer, my dear? You put it in terms of Z matrix, that's it. V1, V2, I1, I2. You take up I1, I2. V1, V2, I1, I2. What is Z11? Z11 is equals to this one or not? J omega L1. Z12 is nothing but J omega M. Next. Z22, this is V2 and I2. This will be Z22, na? Z22 will be J omega L2. And Z21 will be J omega M. All right. So this way we will be getting the probably this could be the answer. J omega L1, J omega M, where it is there? Yeah, D. D could be the answer. Very good, Bhavesh. So these are different kinds of problems you can expect. Uh, that's a reason why I've taken a one model on each and every two-port network. So can you try this one? Can you try this one? What is the voltage gain of the ideal transformer shown below? Voltage gain is asking. Voltage gain means output voltage by input voltage. Voltage gain. Any gain is nothing but output divided by input or not. So he is asking voltage gain. So output voltage is V2 here. Input voltage is V0 here. V2. What is V2? I2 is flowing in this direction. Huh? I2 is flowing in this direction. My dear, please understand. I2 is flowing in this direction in the given circuit. So when the current is flowing in this direction, entering terminal will be positive, leaving terminal will be negative. But given polarities are quite opposite. So V2 I can write it as minus I2 times RL. RL anyhow I know that is 10. You have to calculate V0. What is V0? V0 is input voltage, right? So input voltage you can take up here. 100 I naught minus or otherwise 100 I naught and 20 times this current. This current is how much? I naught is entering and 10 I naught is entering. So combinedly leaving as 11 I naught. So V0 is going to be 100 I naught plus 20 times 11 I naught. So this is your equation. So if you can replace I naught in terms of I1 or something else, then you can do it. By the way, calculate. So this you just simplify, you will get it now. So minus I2 times RL is 10. And this denominator is completely in terms of I naught. No, 100. This is going to be 11. 2s are 22. 220 plus 100. 220 plus 100. 320 I naught. What is I naught? What is I naught? I naught. I naught is here. Nah, I naught is here. So I can write here. If you look at this one, 10 I naught is moving in this direction. I1 is moving in this direction. So I can write I1 is equals to minus 10 I naught. Right? I1 is equals to minus 10 I naught. So I can replace I naught is equals to I1 by minus 10. I1 is equals to, I naught is equals to I1 by minus 10. So in this way, if you can do, then I2 into 10 divided by 32 times I1. So probably, so this could be the answer. Okay, you can even still replace I2 and I1. How do you replace I2 and I1? Or otherwise I2 in terms of I1 or I1 in terms of I2? It is a transformer. Do not forget transformer. It's a transformer. Na? So there is a relation between I2 and I1 in terms of turns ratios. That's the reason why he has given 1 is to 10. 1 is to 10. So N1 I1 is equals to N2 I2. N1 is 1. I1 is, we do not calculate. So N2 is 10. I2 is how much? I2. The I2 actually it should be outwards, sir, but it is inwards. So let me take up minus. So I2 you'll be getting it as minus I1 by 10. So minus I1 by 10, 10, 10 gets cancelled. So probably minus 1 by 32 is going to be the, are you getting, no, be careful with the direction. Probably 3.125 is also there and minus 3.125 is also there. So be careful. Here, actually, if the current is entering into the transformer, the secondary side current should leave. That is magnetomotive motive force balance. It looks like Lenz law is going to be satisfied. Lenz law is going to satisfy. Okay. Probably did I made any, but according to given polarities, okay. I do. If I miss any polarity, you can check. Probably this is a procedure anyhow. So according to the given current direction, I have taken. But I2 should be out of the secondary so that magnetomotive force balance is going to happen. Equal and opposite. People are getting D. Maybe 1 by 32 will be obviously 3.125. So, but be careful. This is negative or positive. Negative or positive. Current direction, be careful. Okay. So that is very, very important. All right. So these are some questions on two-port networks. You can even take up some questions on two-port network, like when uh, two-port networks connected in series. Two two-port networks connected in series. Connected in series. So then the total you can add up their impedances actually. So ZA plus ZB. When two-port networks connected in parallel, you can add their admittance YA plus YB. When two-port networks connected in cascade connection, you can you can multiply their ABCD parameters. You can multiply their ABCD parameters, A1 into A2 into A3 and so on. Yeah, remember these kind of statements. Condition for symmetry, condition for reciprocal networks also is tried. A1 psi, I did not take resonance. No, actually, according to the what I'm saying, uh, according to the topics I am going on, let's see. Maybe the resonance, maybe the sinusoidal steady state analysis, maybe at the end. Is this the end topic? Is this today? Today is this the last topic? Tomorrow is also there, no? Power and power factor. So maybe power and power factor. Some questions. Okay. Hemant it is actually planned in from what I can say from Gradeup backend team. They are going to take up some important topics, so they have listed according to that. Definitely, we'll plan. If not in this, maybe in other series also you are going to get right. So this is all about super subscription. This is all about super subscription. If you subscribe for super subscription, you'll get you can access multiple content of the multiple courses. And by the way, you will be getting the green card also, complimentary green card to attempt the test series freely. These are the Gradeup Super subscribers and the rankers in 2021. All right. So once again, please post your doubts and questions onto my Telegram channel and just tag me. I'll try to reply. Okay, as soon as possible. If you do not get a reply, post it once again. I'll definitely reply. All right. Thank you. Thank you so much. Have a nice day. Thank you, everyone. Thanks for the live session.